Hey guys, I'm Venkat. In this video, we'll discuss how to build a REST API from scratch. Along the way, you'll learn various aspects of building effective APIs using the latest framework from Microsoft, .NET 5. You can download the complete project source code from the link shown on the screen. I'll have this link available in the description box below this video. Before we proceed, a quick tip. If a YouTube video is too slow or too fast, you can adjust the playback speed using this settings icon. If a video is too fast, you can reduce the playback speed maybe to 0.75 or even 0.5. If it is too slow, you can bump it up to 1.25 or 1.5. I play most YouTube videos at this speed, 1.25. So, in this video, we want to build a REST API from scratch using .NET 5. Basically, we want to build an API that provides employee and department data. For example, we want the employee data to be available at an endpoint that looks like the following. The protocol that is used here is HTTP. We can also use HTTPS to be a bit more secure. prajimtech.com is the domain. The path/API in the URI indicates that this is an API. This is just a convention that most people follow. With this convention, just by looking at the URL, we can say this is a REST API URL. Finally, /employees is the endpoint at which we have the resource, that is, list of employees in this case. Similarly, we want the department's data to be available at an endpoint that looks like the following. So, in a REST API, each resource is identified by a specific URI. For example, the list of employees are available at this URI /API/employees. Similarly, the list of departments are available at this URI /API/departments. Along with the URI, we also need to send an HTTP verb to the server. The following are the common HTTP verbs. It is this HTTP verb that tells the API what to do with the resource. The following are the 4 common operations that we do on any resource. For example, create, read, update, or delete a resource. To create a resource, we use the HTTP verb post. To read, get. To update, put a patch, and to delete, delete. So, the combination of the URI and the HTTP verb that is sent with each request tells the API what to do with the resource. For example, the HTTP verb get to the URI /API/employees gets the list of all employees. The same HTTP verb get to this URI, that is /API/employees/1 gets the employee with ID equals 1. Post verb to the URI /API/employees creates a new employee. The verb delete to the URI /API/employees/1 deletes the employee with ID equals 1. The verb put a patch to the same URI updates employee with ID equals 1. What's the difference between put and patch? Well, put updates the entire object, that is first name, last name, date of birth, gender, email, etc. of an employee. Basically, all the properties of the object are updated. Patch is used when you want to do a partial update, that is only a subset of the properties, maybe just first name and gender of an employee object. If you're new to REST APIs, we discussed what is a REST API in detail in this video. Solution layout. This is the same project we've been working with so far in this video series. Take a look at the projects we have in the Solution Explorer. We created this project using Blazor WebAssembly app template. We have 3 projects generated by Visual Studio 2019. Blazor project.client. This is a Blazor web project that runs on the client side in the browser. Blazor project.server. This project does 2 things. Contains REST API that provides data to Blazor client project and also hosts the Blazor client project. Blazor project.shared, as the name implies, this project is shared both by the client and server projects. It contains the model classes used by both the projects. At the moment, as you can see in the shared project, we have 2 classes, that is department class in this file, department.cs, and as you can see, this class is pretty straightforward. It has just 2 properties, department ID and department name. And if we take a look at this file, employee.cs, we have employee class here. We have several properties here: employee ID, first name, last name, email, etc. These are pretty straightforward. Notice this property here, department ID. Basically, it is of type integer, so it contains the integer value of the department to which this employee belonged to. And then we also have a navigation property here, department, and the type is department. So basically, this property contains both the integer department ID value as well as the department name. So if we have a web page where we are displaying a department name, we don't have to make another round trip to the database. This property comes in very handy. And then in this file, gender.cs, we have our gender enum with 3 options: male, female, other. Next, adding database support. To add database support, we'll use Entity Framework Core 5. Install these 3 NuGet packages in the order specified. First, Entity Framework Core, followed by that, Entity Framework Core.SQL Server, and finally, Entity Framework Core.Tools. In Visual Studio, there are several ways to install NuGet packages. I'm going to use Package Manager Console. If you don't see the Package Manager Console option here, click on View, Other Windows, and then Package Manager Console. In the Package Manager Console, from the default project drop-down list, make sure you have Blazor project.server selected, because it is this server project that uses Entity Framework to retrieve data from the underlying database. And here is the command to install our first package, Microsoft.Entity Framework Core. Finally, Entity Framework Core.Tools. Done. All the 3 required packages are installed. One of the very important classes in Entity Framework Core is the DB context class. This is the class that we use in our application code to interact with the underlying database. It is this class that manages the database connection and is used to retrieve and save data in the database. In the server project, first let's create models folder. In this folder, let's add a new class file. Name it app.dbcontext. To use Entity Framework Core built-in DB context class within our application, we create a class that derives from the DB context class. Bring in the required namespace, Microsoft.Entity Framework Core. Next, include the constructor. In the constructor, include DB context options object, and then pass this options object to this base class, that is DB context class constructor. And for that, we simply use the base keyword and to it pass the options object. If you're wondering why is this options object required? Well, for the DB context class to be able to do any useful work, it needs an instance of the DB context options class. It is this instance that carries configuration information such as the connection string, database provider to use, etc. At the moment, in our application, we have 2 entities, department and employee. So within this app DB context class, we need 2 DB set properties, one for the employee entity and the other for department. Let's bring in the required namespace. We'll use these DB set properties to query and save instances of employee and department classes. So the link queries against these DB set properties will be translated into SQL queries against the underlying database. Now, here's the important point to keep in mind. For each of these DB set properties, Entity Framework will create a table in the underlying database. Since we have 2 DB set properties, 2 tables will be created, employees and departments. Now, what we want to do is include some initial seed data in both these tables. And we do that by overriding on model creating method. Notice the moment I type override and press spacebar, we see all the methods that we can override, and the method that we want to override is on model creating. In the interest of time, I'm going to paste some code here, and if you look at this code, it's pretty straightforward. First, we have the code to seed departments table. In the departments table, we'll have 4 rows: ID, HR, payroll, and admin, and then we are seeding employee table. Next, we need to include the database connection string in this file, appsettings.json. Let me include the database connection string at the top. I'm using Microsoft SQL Server LocalDB. So the server is LocalDB, MS SQL LocalDB. the database name is EmployeeDB, but you can give it any meaningful name you want. I'm using Integrated Windows Authentication, so trusted connection equals true. Next, we need to configure SQL Server services, and we do that in configure services method of the startup class. And the startup class is present in this file, startup.cs. In this configure services method, to configure SQL Server, all we need is this one line of code. Notice on this incoming iService collection object, we are using addDBContext class to specify our specific application DB context class. And if you remember, our application DB context class is present in this file appdbcontext.cs, and the class name is appdbcontext, and this is the namespace in which it is present. So let's first bring in that namespace by pressing Ctrl-. And useSQL Server is present in a different namespace. Again, let's bring in the required namespace. If we take a look at our application configuration file, that is this appsettings.json, notice our database connection string key is DB connection. And we are using this same key here in configure services to read the database connection string from appsettings.json. Next, we need to create and execute database migrations. To create a database migration, we use add migration command. To execute and apply a migration on the database, we use update database command. If you're new to migrations, we discuss them in detail in this part 50 of ASP.NET Core tutorial. In Visual Studio, to create a migration, go to Package Manager console. In the default project drop-down list, make sure our Blazor server project is selected, and the command to add a migration is add-migration. We also have IntelliSense and auto-completion available. Type part of the command and then press the tab key. The command that we want is add migration. Use the up and down arrow keys to select the command and then press the tab key again. Let's name this migration initial create and then press the enter key. There we go. We have migration added, and if we take a look at our server project, notice now we have this migrations folder, and within this we have this initial create migration, and here we have all the code required to create the database and the respective tables. Next, we need to apply this migration, and to apply the migration, again we go to the Package Manager console, and the command is update database. Migration successfully applied. If we now go to SQL Server Object Explorer, by the way, if you don't find SQL Server Object Explorer here, click on View and then SQL Server Object Explorer. So within SQL Server Object Explorer, expand SQL Server node and then localDB, MS SQL localDB, databases, EmployeeDB database. That's the database name we specified in our application configuration file, that is appsettings.json. And if we expand our database and then tables, we see both the tables here, departments and employees. Let's see the data that we have in the departments table. Notice we have our seed data in it, and similarly in the employees table also we have our seed data. Next, we're going to use repository pattern to work with data our API needs. So what is a repository pattern? Well, it's an abstraction of the data access layer. It hides the details of how exactly the data is saved or retrieved from the underlying data source. The details of how the data is stored and retrieved is in the respective repository. For example, you may have a repository that stores and retrieves data from an in-memory collection. You may have another repository that stores and retrieves data from a database like SQL Server, for example. Yet another repository that stores and retrieves data from an XML file. Now, take a look at this interface. This is the repository interface. As you can see, this interface only specifies what operations, that is methods, are supported by the repository. The data required for each of the operations, that is the parameters that need to be passed to the method, and the data the method returns. As you can see, the repository interface only contains what it can do, but not how it does what it can do. The actual implementation details are in the respective repository class that implements this repository interface. We want this employee repository to support all these operations. Search employees by name and gender, get all the employees, get a single employee by ID, get an employee by their email address, add a new employee, update and delete an employee. The details of how these operations are implemented are in the repository class that implements this iEmployee repository interface. We want to add employee repository interface in the models folder. So let's right click on the models folder, add new item. We want to add an interface, so select that, and the name of the interface is iEmployee repository. Click add. Make the interface public. And let me paste all the operations that we have just seen on the slide. Bring in the required namespace of this employee class and gender enum. Next, we need to provide implementation for this interface iEmployee repository. So let's add the implementation class again in the same models folder. We want to be able to retrieve and store employee objects in a SQL Server database. So let's make this class implement the interface iEmployee repository. To be able to interact with SQL Server database, we need an instance of our application DB context class, and that class is again present in this file appdbcontext.cs in the models folder, and this class inherits from the built-in DB context class. So this class knows how to retrieve and store employees from a SQL Server database. So let's inject this class into our employee repository using a constructor. Let's call the parameter appdbcontext and use control period to generate a private field. We are using dependency injection here to inject an instance of appdbcontext class. If you're new to dependency injection, we discussed it in detail in part 19 of ASP.NET Core tutorial. First, let's provide the implementation for this add employee method. On the injected appdbcontext instance, we have employees collection property. To this collection, we want to add a new employee. So for that, we have add async method. To this method, let's pass the incoming employee object. As the name implies, this method is an async method. So let's await its execution and then store the result in a variable called result. Since we are using await keyword here, we have to turn this method into an async method. Next, to save this employee object in the underlying SQL Server database on the injected appdbcontext instance, we have save changes async method. Again, this is an async method, so let's await its execution as well. And then finally, we want to return the added employee back to the caller. For that, on the result object, we have entity property. We want to return it, so let's use the return keyword. Next, let's provide implementation for this delete employee method, and here is the code for that. First, let's fix these compilation errors. We are using await keyword, so let's turn this method also into an async method, and this first or default async method is present in Microsoft.Entity Framework core namespace, so let's bring that in. To be able to delete an employee, we need the respective employee ID, and that is passed into this method as a parameter. We're using that parameter and trying to find if we have such an employee in the underlying employees database table. If result not equal to null, meaning if we have found the employee, we are then removing that employee from the employees collection property on our appdbcontext instance and then calling save changes to remove that employee permanently from the underlying database table. Next, let's provide implementation for this getEmployee method. As usual, to fix the compilation errors, let's turn this method into async. This method finds employee by ID and returns that employee. The employee ID is passed as a parameter. So as usual, on the appdbcontext instance, on the employees collection property, we are trying to find if we have an employee with the incoming employee ID. If we have, we are returning that employee back. But what does this include doing here? Well, if you take a look at the definition of our employee class, notice we have department property. So when we return the employee instance, we also want to populate this department property. And to do that, we are using this include property to include department data from the underlying departments table as well. Next, let's provide implementation for this getEmployee by email method. Same idea here. On the employees collection property on our app.db context instance, check if we have an employee with the provided email address. If we do, then return that employee. Let's not forget to turn this method into an async method. Similarly, we want our getEmployees method also to be async. So first, let's convert it into an async method. As the name implies, this method returns all employees. So on the employees collection property, we are calling toList async and returning that list. Next, search. As usual, let me paste the code and turn this method into an async method. We want to be able to search employees by both name and gender. Both of them are being passed as parameters. And then we are building our query dynamically here. First, the query will contain the collection of all employees. And then if the incoming name is not null or empty, meaning if a name is provided, we are building the where clause dynamically. And if you look at the where clause here, we are checking both first name and last name. And at the moment, we're using contains. We can also use starts with or ends with depending on our search requirement. Similarly, if the incoming gender parameter is not null, meaning if a value is provided for gender, then we are adding another condition here. Finally, returning that list back to the caller. So pretty straightforward search here. Finally, let's provide implementation for update method. And here is the code for that. As usual, let's convert this method to async first. We pass the employee object that contains our changes as a parameter to this update employee method. And then we are using the employee ID property on this incoming employee object to find that respective employee in the underlying database table. If we have found the employee, then we are overriding all the properties of the existing employee with the values that we have in this incoming employee object. And then finally call save changes async on the app.db context instance and then return the updated employee object back. Just like employee repository, we need another repository for departments. Here's the department repository interface. Pretty straightforward. At the moment, it only supports two operations. Get departments, as the name implies, this method is going to return us the list of all departments. Get department, this method returns a single department by ID. We provided the ID and this method returns the matching department. Here is the implementation. The pattern is very similar to employee repository. First, we inject our application DB context class using dependency injection, and then this get department method looks up the department by ID and returns that department. And get departments returns the list of all departments. In the interest of time, I've already added both these files, that is department repository and its implementation department repository. Again, both these files are present in this same models folder. In configure services method of the startup class, we need to include these two lines of code. Why? Well, we need to tell .NET which implementation to use. With these two lines of code in place, an instance of department repository class is provided when an instance of department repository is requested. Similarly, an instance of employee repository class is provided when an instance of employee repository is requested. At the moment, if you notice, we are using add scoped method because we want the instance to be alive and available for the entire scope of the given HTTP request. For another new HTTP request, a new instance of employee repository class will be provided and it will be available throughout the entire scope of that second HTTP request. In addition to add scoped, we also have add singleton and add transient methods. We discussed the difference between these three methods in detail in this part 44 of ASP.NET Core tutorial. In the interest of time, in configure services method of our startup class, I've already included those two lines of code we have just seen on the slide. So basically, these two lines of code tie the repository interfaces with their respective implementation classes. What are the benefits of a repository pattern? Well, there are many. The code is cleaner and easier to reuse and maintain. Enables us to create loosely coupled systems. For example, if we want our application to work with Oracle database instead of SQL Server database, implement an Oracle repository that knows how to read and write to Oracle database and register Oracle repository with the dependency injection system. In an unit testing project, it is easy to replace a real repository with a fake implementation for testing. Our next step is to create the REST API itself. In .NET, to create a REST API, we create a controller class that derives from the built-in controller base class. Actually, our controller class can either derive from the built-in controller or controller base class. One confusion here is which built-in class to use as the base class. Well, the answer is very simple. If you're creating a REST API, make your controller class derive from controller base and not controller class. Controller actually derives from controller base and it adds support for MVC views. So create a controller that derives from controller class if you're building an MVC web application. On the other hand, if you're creating a REST web API, create a controller class that derives from controller base class. So in short, controller is for MVC web applications and controller base is for MVC web APIs. If you're planning to use the controller both for a web application and for a web API, then derive it from the controller class. In our Blazor server project, in the controllers folder, let's add a new controller. Let's name it Employees Controller. In our case, we are building a web API and not a web application. So let's make our controller class derive from controller base, bring in the required namespace. Since we are building a web API controller, we also need to decorate our controller class with API controller attribute. To specify the route at which this controller is available, we use the route attribute. We want all our API controllers to be available at this path, API / the name of the controller. To specify the name of the controller within square brackets, we use the word controller. With this in place, if the name of the controller is employees controller, then this controller is available at the path API / employees. And if the name of the controller is departments, then it's available at the path API / departments. Now, we want our employees controller to be able to retrieve data from SQL Server database. If you remember, this employee repository does exactly that. So we want to inject the interface employee repository into our employees controller. For that, we need a constructor. Using this constructor, let's inject the interface employee repository. We need to bring in the required namespace as well. Let's do that by pressing Ctrl period, and let's call the parameter employee repository. And also generate the required private field by pressing Ctrl period again, and then select the second option. Next, let's include a method that's going to return the list of all employees. This method is going to be public, async, and it's going to return task of action result. And let's call this method getEmployees. When a GET request is issued to this path, API / the name of the controller, in our case employees, we want this getEmployees method to be called. And to specify that, we decorate our method with HTTP GET attribute. If we want a method to handle HTTP POST request, then we decorate it with HTTP POST attribute. We'll discuss these common HTTP attributes, that is HTTP POST, PUT, and DELETE, in just a bit. For now, let's make this getEmployees method return the list of employees. And for that, we're going to use this injected employee repository. Notice on this employee repository instance, we have getEmployees method that's going to return the list of all employees. And this getEmployees method is an async method. So let's await its execution. When I hover the mouse over this getEmployees method, notice it returns an enumerable of employee objects. And this is what we want to return from this getEmployees method. So let's use the return keyword. And I am also going to wrap this result using the built-in OK method. If you're wondering, where is this OK method coming from? Well, it's coming from this controller base class from which our employees controller is deriving from. When I hover the mouse over this OK method, notice this method returns the HTTP status code 200 OK along with the list of employees. What we are building here is an API. It's common for an API to return an HTTP status code. these HTTP status codes tell the client, that is the caller of our API, the status of the request. For example, when this getEmployees method completes execution successfully, it returns the list of employees along with the status code 200 OK. Some of the common HTTP status codes are listed here. 200 OK if the request has completed successfully. When we create a new resource, for example, when we create a new employee, we use the status code 201 created. If a resource cannot be found, for example, if we cannot find an employee with the provided ID, we use the status code 404 not found. Similarly, if there is an internal server error processing our request, we use the status code 500. You can find the complete list of HTTP status codes and their use on this Wikipedia article. When this method getEmployees completes execution successfully, then we want to return the list of employees along with the HTTP status code 200 OK. But what if there is an error processing this request? Well, in that case, we want to return the HTTP status code 500, which indicates there is an internal server error processing this request. So let's wrap this line of code in a try-catch block. For that, simply type the word try and then press the tab key twice. It automatically generates the stub, as you can see right here. And let's move this call to getEmployees method inside the try block. If there is an exception executing this line, we want to return the HTTP status code 500. For that, we use status code method, and we also use the enum status codes. This enum is in a different namespace, so let's bring the namespace in. And notice from the IntelliSense, there are several status codes here. Status 200 OK, status 204 no content. In our case, we want to return status 500 internal server error. And then we can also include a message. So if the request completes successfully, then we return the list of employees along with the status code 200 OK. If there is an exception, we return the status code 500. On this slide, you can see the common HTTP status codes along with the built-in helper methods that we can use to return these status codes. For example, to return the status code 200, we use the built-in method OK. For 201, created. For 404, not found. And for returning 500 series HTTP status codes, we use the status code method. You've seen this method in action just now. At this point, let's run our application by pressing Ctrl F5. There we go. We see the Blazor web page. But what we really want to do is invoke this getEmployees method of employees controller. And the path to get to that is API / the name of the controller. The name of our controller is employees. So we use this path to get to our API / employees. There we go. We have all our 4 employees in JSON format as expected. Now let's quickly test our API in Postman as well. I have Postman up and running. In this text box, enter the API URL and we want to issue a GET request. So from this drop-down list, make sure the HTTP verb GET is selected and then click this button, Send. Request completed, and we are looking at the response body at the moment. And notice we are on Pretty tab, meaning the JSON result that we have is formatted, so it's pretty and easier on the eyes. If you want to see the raw JSON data, click on this tab, Raw. So here we see all our 4 employees in raw JSON format. And here on the right hand side, we also see the HTTP status code 200 OK. Next, let's see how to retrieve a resource by ID. For example, employee by ID. At the moment, when we issue a GET request to this URI /API/employees, we get the list of all employees. Now, we want to retrieve a specific employee. For example, employee whose ID is 1. For this, again, we issue a GET request, but this time the URI is /API/employees/1. The value 1 is the ID of the employee. In the employees controller, let's include another method. This method is going to retrieve employee by ID, and it's going to be very similar to this getEmployees method. So let's make a copy of this and then change the bits that are required. First, let's change the name of the method from getEmployees to getEmployee singular, because this method is going to return just one employee, and we want to pass the ID of the employee whose details we want to retrieve as a parameter. Let's also change the return type. We know this method is going to return a single employee. So let's change the return type to task of action result of employee. Now, here's the important bit. I'm going to slightly modify this HTTP GET attribute. First, I'm going to include a pair of parentheses, and then a pair of double quotes, and then finally a pair of curly braces, and then ID. What we are doing here is including an extension to our API route. So if we navigate to this route, API/employees, then this getEmployees method is called, and it returns the list of all employees. But in the URI, if we have the ID of the employee, for example, if we navigate to API/employees/10, 10 is the ID of the employee, then we want this getEmployee method to be called, and it should return that employee whose ID is 1. And to specify that, we are including an extension to our route. So all that is left right now is to use this incoming ID. So whatever ID value that we have in the URI is automatically mapped to this ID method parameter. And using that, we can retrieve the specific employee. On our employee repository, we already have getEmployee method. And to this method, we pass the incoming ID. Let's store the result that we get back in a variable. Name the variable result. If result is null, that means we have not found the employee with the provided ID. So we want to return 404 not found HTTP status code. For that, we use not found built-in method. Else, we return the result. In our case, the result is the single employee object we have found. .NET is going to automatically serialize this employee object to JSON format and write it to the response body. This response body, along with the HTTP status code 200 OK, is then returned to the client, that is, to the caller of our API. Now, here's another important point to keep in mind. On this employee ID route parameter, we can also include a route constraint. And we do that by including a colon and then the data type that we are expecting. In our case, employee ID is an integer, so we specify int. With this change in place, this URI is only mapped to getEmployee method if the ID value data type is integer. If it's of any other data type, then this URI is not mapped to getEmployee method. At this point, let's run our project and test this getEmployee method. In Postman, in the URI, let's include employee ID value. In this case, I included 1, and we want to issue a GET request. So let's click send. There we go. We have the respect to employee details along with the HTTP status code 200 OK. Now let's include an ID value that does not exist. For example, we don't have an employee with value 10. So let's click send. Notice now we have status code 404 not found. Next, let's see how to create a new employee, that is, implement post in a REST API. Now, to get the list of resources, in our case, list of employees, we issue a GET request to this URI /API/employees. To get a specific employee, again, we issue a GET request, but this time in the URI, we include the ID of the employee whose details we want to retrieve. To create a new resource, that is, in our case, to create a new employee, we issue a post request to this URI. Notice the word employees is plural, and posting to this collection URI /API/employees makes sense because to this collection of employees, we want to add a new employee. In employees controller, we need a new method to implement post. The signature of this new method is going to be somewhat similar to this getEmployee method. So let's make a copy of this method and then change the bits that are required. First, to keep the method name meaningful, let's change it from getEmployee to createEmployee. Next, pass the employee object that we want to create as a parameter to this create employee method. So the data type is employee, and let's also call the parameter employee. The created employee object will be returned back. So the return type of this method is task of action result of employee. And to implement post, we use the HTTP post attribute. Now, let's replace all these lines of code in the try block with this one line. What we are doing here is returning 200 status code for now. So let's place a breakpoint here on this line and then run this API project in debug mode. To create a new employee, to this collection URI /API/employees, we issue a post request, and we also need to send employee data along with the request. We do that using request body. So click on body, and we're going to send the JSON data in raw format. So from this drop-down list, we select raw, and then we also need to select the format. We are going to send the data in JSON format. So I select that, and then we include our employee object right here. We don't have to provide a value for this employee ID property. Why? Well, because employee ID column in the underlying employees database table is an identity column. This means SQL Server will automatically provide the value. It also automatically populates this property upon successful employee creation. We'll see that in action in just a bit. For now, let's remove this property and then issue a post request by clicking this send button. Our breakpoint is set. And notice when I have the mouse over this employee parameter, we can see the employee data that we have in the request is automatically mapped to the properties on this employee object. Notice the value of employee ID property, it's 0. Why? Because we didn't supply a value for this property and the data type is integer. The default value for integer is 0, which is what is used as the value at the moment. But upon successfully creating a row for this employee in the employees database table, SQL Server will automatically provide a new identity value, and this property will be updated with that new identity value. We'll see that in action in just a bit. But here's the important question that we should be asking at this point. How is .NET able to map the employee data that we have in the request in JSON format to the respective properties on this employee parameter? Well, that's happening by model binding, and model binding is working as expected at the moment because we have decorated our employee controller with API controller attribute. So for model binding to work, that is for .NET to be able to map the employee data that we have in the request to the respective properties on this employee parameter, we should do one of the two things: either decorate our employees controller with API controller attribute or decorate this method parameter with from body attribute. So now let's stop debugging and implement the rest of the code. In the interest of time, let me paste the required code. I'll walk you through this code in just a bit. Before we forget, let's change the error message here to error creating new employee record. Now, we are first checking if this incoming employee parameter is null. If it is null, then the request is a bad request. Why? Because we cannot create a new employee row without employee data. And as you can see from IntelliSense, the status code for bad request is 400. If employee parameter is not null, then we are passing it to add employee method of our employee repository. This method will create a new row for the employee in the database table, and the newly created employee object is then stored in this variable. Now, here's the important bit to understand. What is this line of code doing? Well, when a new resource is created, we usually do the following three things. Return the HTTP status code 201 to indicate that the resource is successfully created. We also return the newly created resource, in our case, the newly created employee object. Finally, location header in the response. The location header specifies the URI of the newly created employee object. This seems like a lot of work, but it's actually very easy to implement than it sounds. We are using the built-in created at action method. Notice when I hover the mouse over this method from the IntelliSense, you can see this method returns the status code 201 to indicate that the resource is successfully created. Keep in mind, on a successful post, one of the things that we have to do is in the response include the location header, that is the URI at which the newly created employee is available. For example, let's say this method creates a new employee with ID value of 5. So this newly created employee will be available at this URI /API/employees/ the employee ID value, in this case 5. If you recollect, it is this getEmployee method that returns employee by ID, and we are using this method to generate the location URI. And notice here we're using name of keyword instead of hard coding the method name in a string. And the obvious benefit of this is later, if we rename getEmployee method and we forget to change it here, the compiler will immediately flag it as an error. And for this getEmployee method to be able to retrieve employee, it needs the employee ID value. And notice the parameter is named ID, and we have to supply the newly created employee ID value. So we are using an anonymous object for that, and obviously the parameter name is ID. And where are we getting the newly created employee ID from? Well, we have it in this variable. So created employee.employee ID. And then the last parameter is the newly created employee object itself. So with all these changes in place, let's build our project and test it again using Postman. In Postman, to this collection URI /API/employees, we want to issue a post request. Along with the post request, we also want to send the employee data, and we do that using request body. And I already have the employee object here, and within request body, make sure from the first dropdown you have raw selected, and in the second dropdown JSON selected. When creating a new employee, we don't have to supply a value for employee ID property. So let's remove this from the object we are sending to the server, and then click send. Request completed, but we have HTTP status code 500 internal server error. And the error message is error creating new employee record. It is this same exception message that we have right here. So let's see what exception we are getting. For that, let me include a variable for this exception parameter, put a breakpoint, and then run our project in debug mode. Issue post request again. Our breakpoint is hit. When I hover the mouse over this exception parameter, take a look at the exception message we have. Cannot insert explicit value for identity column in table departments. We are trying to insert a row in employees table. Why is it complaining about departments table? Well, that's because if we take a look at the request we have in Postman, notice we are sending an entire department here. So what Entity Framework is trying to do is create a row for department with department ID 1. And if you remember, department ID column in the departments table is an identity column, and we don't have to supply a value for the identity column explicitly. And that is the exception that we are getting. There are several ways to fix this. One of the ways is to simply set department property to null when we are issuing a request. Since we already have department ID integer property here, this value will be stored in the department ID column in employees table. And another way is to tell Entity Framework to ignore this department entity. And this is better because when a client sends department data, we don't want an exception like this. So let's tell Entity Framework to not do anything when a department is sent along with the employee object. And we do that in employee repository. So we have our employee repository here and add employee method. This is where we tell Entity Framework to ignore the department entity. So let's stop debugging. If department property on the employee object is not null, we are telling, the state of department entity is unchanged. So Entity Framework is not going to try and create a new entry for the department in the departments table. With these changes in place, let's build our project and test again in Postman. Issue post request again. Request completed with HTTP status code 201 created. And we have our newly created employee object here. Take a look at the employee ID property. The value is 5. And if we take a look at the response headers, specifically the location header, we have the URI where our newly created employee object is available /API/employees/5. Let's copy this URI and issue a GET request to it. There we go. Status code 200 OK along with the employee object in the response body. Next, let's understand how to implement model validation in a REST API. ASP.NET 5 provides several built-in attributes for model validation. Required attribute, this attribute specifies a field is required. Range attribute specifies the minimum and maximum allowed value. Min length specifies the minimum length of a string, max length, maximum length of a string. Compare compares two properties of a model. For example, compare email and confirm email properties. Regular expression validates if the provided value matches the pattern specified by the regular expression. Let's see some of these validation attributes in action. In our solution, model classes are present in this project, Blazor project.shared. To be able to use the built-in validation attributes, we'll have to bring in a NuGet package. So let's do that using Package Manager console. Within the Package Manager console, from this default project drop-down list, select Blazor project.shared and then execute this command: install package system.componentModel.annotations. There we go. Package installation complete. Now, in a .NET 5 REST API, to implement model validation, all we need to do is decorate the respective model class properties with validation attributes. In our case, we want to implement model validation for our employee model class. So let's open employee.cs from our Blazor project.shared. Let's make this first name property a required property. And for that, all we need to do is decorate it with required attribute. This attribute is in a different namespace, so let's bring that in by pressing Ctrl:. Let's also make last name required. While we are here, let's also enforce minimum length validation on first name. We want first name to contain at least 2 characters. In Postman, notice I have deliberately set first name to just 1 character. Let's remove last name and then send this request to the server. Request completed with HTTP status code 400 bad request. And if we take a look at the response body, notice we have our validation errors. Last name field is required. The field first name must be a string with a minimum length of 2. Now, if you don't like these error messages, you can very easily change them using the error message property of the respective validation attribute. For example, I'm changing the min length validation error message to first name must contain at least 2 characters. Now, if it's an ASP.NET MVC web application that we are developing, then we explicitly check if model state has succeeded or failed by using modelState.isValid property. In an ASP.NET REST API, there is no need to explicitly check modelState.isValid property. Now, if we take a look at employees controller, notice it is decorated with the API controller attribute. So it is this API controller attribute that takes care of checking if the model state is valid. If it is not valid, it automatically returns the HTTP status code 400 along with the validation errors. Now, most of our validation requirements can be implemented using these built-in attributes. However, there are few use cases which we cannot implement using these built-in validation attributes. For example, let's say we do not want to allow a new employee to be created if the provided email is already in use. Let's see how to implement this now. If we take a look at our employee repository class, notice we already have a method here, getEmployeeByEmail. So we provided the email address. This method will check if there is an employee already with that provided email address. So within our employees controller, in this createEmployee method, before we create the employee, let's check if we already have an employee with the provided email. So let's create a variable, emp equals employee repository dot get employee by email, And to this method, we need to pass the email. We have that on the employee object. If employee is not equal to null, it means we already have an employee in our system with the provided email address. So to the model state object, we want to add model error. The key is email and the error message is employee email already in use. And then we return bad request along with the model state object. In our system, we already have an employee with this provided email address, david@presumetech.com. Let's try to create another employee with the same email address and see what's going to happen. There we go. Bad request with the HTTP status code 400 along with our validation error message, employee email already in use. Next, let's discuss how to update an existing resource, that is, implement HTTP put in a REST API. We have already discussed how to retrieve the list of all employees, a specific employee by ID, and even how to create a new employee. To update an existing employee, we use the HTTP verb put, and in the URL, we pass the ID of the employee whose details we want to update. Update employee is going to be somewhat similar to this create employee method. So let's make a copy of this method and then change the bits that are required. First, change the name of the method to update employee. This method needs two parameters, the ID of the employee whose details we want to update and the employee object itself. This object contains our changes, and this method returns task of action result of employee, basically the updated employee object. We'll see that in action in just a bit. And remember, it is the HTTP put verb that we use to update data. In the URI, we also pass the ID of the employee whose details we want to update as a route parameter. So on this HTTP put verb, let's also include the ID route parameter. Employee ID is integer, so let's also include the int route constraint. Remember, the employee ID value that is passed in the URI is automatically mapped to this ID parameter. So let's check if ID equals the employee ID property on the employee object. So basically, we are checking if this ID equals the employee ID property on this employee object. If they are not equal, then that means something went wrong and we do not want to continue updating employee data. Instead, we want to return a bad request with the error message, employee ID mismatch. If the ID values match, our next step is to retrieve the respective employee details from the database table. For that, on employee repository, we have getEmployee method. And this method expects employee ID whose details we want to retrieve. So let's pass the incoming employee ID value, and then let's also rename this variable. Let's call it employee2update. GetEmployee within our employee repository is an asynchronous method. We forgot to use the await keyword. And I think even in createEmployee method, we forgot to use await keyword on this getEmployee by email method. So let's include it here as well. Now, if this variable employee2update is null, it means we cannot find employee with the provided ID. So let's return not found with the message employee with ID equals whatever is the ID, not found. On the other hand, if we have found the employee, we can proceed with the update. So on employee repository, we have update employee method. To it, we pass this incoming employee object, which contains our changes. And if you take a look at this update employee method on our employee repository, this method updates the data in the underlying database table and returns that updated employee object back. So let's use the return keyword here. We don't need this last line anymore, so let's delete that. Finally, let's also change the error message here to error updating employee record. Run the project and test HTTP put using Postman. From Postman, we want to issue a put request. And here is the URI, API/employee/1. One is the ID of the employee whose details we want to update. And we want to send the employee object that contains our changes using the request body. And we're going to use raw JSON format for that. And here is the employee object. Let's change first name to John with letter H and last name to Hastings. And let's also change email to john@pragimtech.com. Let's click send. There we go. Status code 200 OK. And in the response body, we also have the updated employee object. Notice these three properties, first name, last name, and email. We have the updated values. Now, take a look at this update employee method within our employees controller. It calls update employee method on our employee repository, and we have that method right here. And to this method, we pass the employee object that contains our changes as a parameter. We first retrieve the respective employee object from the database table using the employee ID, and then overwrite each property with the updated values that we have on this incoming parameter employee object. And for department ID, we are using the integer department ID property. But if we take a look at Postman, there are two ways to send department ID value. We can either use the integer property department ID or this complex object department. Notice it also has department ID property. At the moment, this method within our employee repository is simply ignoring the department object. So we want to make this method a bit more intelligent. So I'm going to replace this one line of code with these 4 lines. Pretty straightforward logic, nothing too complex here. We're first checking the integer department ID property value. If it's not the default integer value, which is 0, that means we have got a value within the department ID property. So let's use that integer property. Else, check the department property. If it is not null, then use the department ID property on the department object. Next, let's discuss how to implement delete in a REST API. To retrieve the list of all employees, we issue a GET request to this URI. To create a new employee, again, to the same URI, we issue a POST request. To retrieve, update, or delete a specific employee, we issue either GET, PUT, or delete request to this same URI. Notice in these last 3 cases, we are passing the ID of the employee in the URI. Delete employee is going to be somewhat similar to this update employee method. So let's make a copy of this and then change the bits that are required. To delete an employee, we just need employee ID. We don't need this employee object parameter. So let's delete that. And to keep the method name meaningful, let's change the name of the method to delete employee. This method is not going to return anything. So let's remove this employee parameter. We can return the deleted employee object back, but to keep the implementation simple, this method is not going to return anything. And it is the HTTP delete verb that we use to delete a resource. Inside the try block, we don't need this if check. To delete an employee, we first retrieve the respective employee from the database using this incoming ID. To keep it meaningful, let's change the name of this variable to employee to delete. If this variable is null, it means we did not find the respective employee in the database with this provided ID. So we return HTTP status code 404 with the message employee with ID equals whatever is the ID not found. On the other hand, if we have found the employee, we want to delete that respective employee. So on our employee repository, for that, we have delete employee method. And to this method, we pass the incoming ID parameter. Upon successfully deleting the employee, let's return the HTTP status code 200 OK. For that, we use the built-in method OK. And we can also return a custom message if we want. Let's actually copy and paste this message. Employee with ID equals whatever is the ID deleted. Finally, to keep it meaningful, let's not forget to change the exception message here to error deleting employee record. At the moment, within our system, we have 5 employees. Let's delete this last employee with employee ID 5. So in the URI, we include the ID of the employee, and the HTTP verb that we used to delete is delete, and then let's send this to the server. There we go. We get status code 200 OK along with the message employee with ID equals 5 deleted. Now let's try to delete this employee again and see what's going to happen. We get 404 not found with our custom error message employee with ID equals 5 not found. And if we try to issue a GET request to retrieve this specific employee, again we have 404 not found. At this point, we have all the CRUD operations implemented, that is create, read, update, and delete. Next, let's discuss how to implement search in a REST API. We want to be able to search by both employee name and gender. As usual, in our employees controller, let's include another method for search. This method is also going to be public async, and it's going to return task of action result of IEnumerable of employee objects. If you're wondering why is the return type IEnumerable of employee objects, well, that's because we want this method to return the list of all employees that match our search criteria. Let's name this method search. Remember, we want to be able to search both by name and gender. Name is of type string and gender is of type enum. Now, here's the important point to keep in mind. We want to make both these search parameters, that is name and gender, optional. If values for these search parameters are not provided, we want the search to return all the employees. If a value for name is provided, search just by name. Along the same lines, if a value for gender is provided, search just by gender. If both are provided, search by both. Name parameter is already optional because name is of type string, which is a reference type, and for a reference type, we can pass null. Gender parameter, on the other hand, is an enum, which is a value type, and we cannot pass null. To be able to pass null and make it optional, let's make this gender enum a nullable enum by including a question mark. At the moment, this getEmployees method is decorated with HTTP GET attribute. This means when we navigate to this URI /API/ the name of the controller, in our case employees, this getEmployees method is called and it returns the list of all employees. Now take a look at this getEmployee method. Even this method is decorated with HTTP GET attribute, but this attribute has an extension to the route. So we have the ID route parameter here. So with this in place, when we navigate to this URI /API/employees/ the ID of the employee, then this method is called and this method returns that specific employee. Same idea with search. We want to include an extension to the route that we already have at the controller level. So I'm going to decorate this with HTTP GET attribute and include an extension to the route that we already have at the controller level. So with this HTTP GET attribute in place, when we navigate to this URI /API/employees/search, this search method is called. Next, let's provide the implementation. First, a try-catch block. If there is an exception performing the search, let's return the HTTP status code 500 along with the message error retrieving data from the database. On this injected employee repository, we already have a search method. So let's call that. And to it, let's pass both these incoming search parameters, name and gender. Now, if we take a look at the search method in our employee repository, its implementation is pretty straightforward. Notice we are building our search query dynamically. We are starting with the full list of employees. And then if a value for name is provided, we are adding the where clause dynamically, basically filtering by name. We are looking in both the columns, first name and last name. And at the moment, we're using contains, but we can also use starts with or ends with depending on our search requirement. Similarly, if a value for gender is provided, then we are filtering by gender, finally executing the query and returning the search results. At the moment, as you can see, this search method is an async method. So let's await its execution and then store the result in a variable called result. Let me paste the rest of the code and I'll walk you through it. If we have at least one employee in the search results, we return the search results along with the HTTP status code 200 OK. Otherwise, 404 not found. Next, let's test our search using Postman. To this URI/API/employees, let's issue a GET request. There we go. In the database, we have 4 employees and we see all those 4 employees. Now, let's navigate to this URI/API/employees/search. This will invoke our search method. And keep in mind, at the moment, we're not providing any values for the search terms. So the list of all employees must be returned. So let's execute this. There we go. We have all the 4 employees as expected. Now let's include a value for the gender search parameter. We do that using a query string parameter. And keep in mind, gender is an enum. So if we look at the enum values, for male, the underlying integer value is 0. For female, it's 1. For other, it is 2. So this means we can either pass the integer value like this. For male, 0. Let's execute this. We get both the male employees. We can also pass the text value, male. Again, we have the same result. Now let's also include a value for name. We get the one employee whose name is John and gender is male. And if we change the gender value to female, we don't have any such employee, so we get 404. In this project, Blazor project.server, in the controllers folder, in the interest of time, I've already added departments controller. The pattern for implementing departments controller is exactly the same as employees controller. Let me open this file and I'll quickly walk you through the code. Take a look at our departments controller class. It's decorated with both these attributes, route and API controller. It also inherits from the built-in controller base class because what we are building here is an API controller. And then we're using the class constructor to inject department repository, which obviously provides database data. Take a look at this get departments method. It is decorated with HTTP get attribute. So this means when we navigate to this URI, API/the name of the controller, in this case, departments, this method is invoked and it returns the list of all departments. Now take a look at this get department method. This method expects the ID of the department as a parameter. And take a look at this HTTP get attribute. Using this attribute, we are including an extension to the route that we already have at the controller level. So in the URI, if we have API/departments/the ID of the department, then this method is invoked and it returns that specific department. So pretty straightforward controller class here. What we have built together in this course is a simple REST API. I hope you've enjoyed this course as much as I did creating it. Thank you for listening. Goodbye for now.